All right, let's go over the sample or over the chapter 6 test. So let's graph these. So this is a parabola that's moved 1 to the right. It's not up or down. So it goes through 1, 0. And at 2, it's a tenth of what it normally is. Normally it's 1, so it's only a tenth. So that's not very much. At 3, it's supposed to be at 2 over, it's supposed to be at 4, so this would be 4 tenths, not quite a half. And at 3 over, 3 squared is 9. 9 tenths is almost 1. And at 5, it's going to be 4 squared, 16, 1.6. 1, 2, 3, 4, 5 over is 25. 1/10 of 25 is 2.5. So, and it does similar going this way. 5 log x. So the log of 1 is 0 times 5 is 0. The log of, let's see, 10 is 1 times 5 is 5. So it goes through there. And it's a log curve, so it's going like this. So it looks like they intersect out there somewhere around 6 or 7 in the x and around 4 in the y. So to find that out for sure, I'm going to graph those two. So 0.1 parenthesis x minus 1 close parenthesis squared. 5 log x. And zoom 6. There's the one. There's the other. Second, calculate the intersection of that curve and that curve. And my guess is, I know the one at 1, 0, but I want to know the one there. And that's point is 7.6 4, 6, and that's close enough, comma, and 4.417. Okay, we need to find the area between them. So we're going to do the integral. We'll just do the integral of 1/10 x minus 1 squared. Well, that's the bottom one. So I'm going to do, let's start this again here. The integral of 5 log x minus 0.1 or 1/10 x minus 1 squared dx. And we're going to integrate from 1 to 7.646. Okay, and so we're going to work that out. So that's y2, and that's y1. So I can go math integral of, I don't want to put it there. Dang it, now I got that gone. Okay, that one was clear. 0.1 parenthesis x minus 1 close parenthesis squared. Second clip, home screen, clear clip. Math 9 from 1 enter to 7.646. 2. 7.646 of, that's y2 vars, that's this button, vars, y variables function y2 minus vars y variables function y1 dx. Enter, and it tells me the area between those curves is 9.557. Okay, that's pretty close. Now, we got to graph ln of x plus 1. So if x is 0 plus 1, basically ln goes through 1, but if I have an x plus 1, it moves it back 1, so it's going to go through 0 and curve up somehow. And we're supposed to do it from 0 to 5. That area in the first quadrant, so this area, up to 5, and by rotating the area in the first quadrant about the x-axis. So they're going to take it down here. So I'm going to slice it vertically, and the point on the graph, any point on the graph will be x, y, so it's over x, and up y, so when I'm rotating it around, y will be the radius. The thickness will be dx. So it'll be the integral, since I'm doing dx from 0 to 5, of pi r squared, so that's y squared, but y is ln x plus 1, pi r squared h, the height of it, which is the thickness of the disk, which is dx. So there's what I need to integrate. And so math 9, see if I can do this right, 0, move over, 5, move over, ln, parenthesis, x plus 1, close parenthesis, I didn't need to put 1 there to delete. That's the ln of that. And I want to, I think I can just do squared. It'll square the whole thing. I think that's going to work. I'm going to check it here in a sec. Enter, and I'm getting 7.76. I think it'll do ln of this first and then square. Yes, 7.761. Okay, page 2. And some of you struggled with this one. Let's see what we got here. We're going to bound it, and we're going to do it over y equals 1, and we're going to have y equals 4. So if I make the x-axis here, and the y-axis, so I don't say here, then y equals x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4, and y equals 4. And I said the part that's in the first quadrant, not the part that's over here in the fourth quadrant, so part that's in the first quadrant. And we're going to rotate it about y equal -1. So if I take a point on the curve and find its coordinates, well, this would be x, and this would be the y. So now if I spin this around this is 1 above, so it'll go for 1 below. So we're looking at the part that ends up down there. So it says disc washer method. So I'm going to slice it perpendicular to the axis. So I'm going to slice it this way. And that would end up making a line here, coming out, around, down, and back. That's the big radius making it circle. And the small radius would be inside here. So I got to go pi integral from, so that's going to be a dx, and x has got to go from 0 to 2. Pi r. Now I got to do the large radius, which is from here to there, and it stays the same size all the way along here. It stays 1, 2, 3, 4, 5. Pi 5 squared dx. But I got to then subtract the inside, which is going to have a radius of y plus 1. Now this would be for the disk method, minus the inside radius squared. Pi large radius squared minus pi inside radius or small radius squared. Now, I need to replace y with something with x, and y is equal to x squared. So this is going to turn into the pi integral from 0 to 2 of 25 minus, here we're putting x squared. So we got x squared minus 1, plus 1 squared dx. Now I either got to work this one out. I'm going to work both of them out, but let's go ahead and work this one out. So to do this one, I'm going to square this. So I'm going to get pi 0 to 2, 25 minus x squared plus 1 squared is going to be x to the 4th plus 2x squared plus 1, and I got to subtract all that. So it's going to be pi 0 to 2. So I've got minus x to the 4th minus 2x squared minus 1 plus 25 is plus 24 dx, integrated pi minus x to the 5th over 5 minus 2x to the 3rd over 3 plus 24x evaluated from 0 to 2. The 0 is not going to produce anything, so I just need to figure out the 2. So I'm going to get pi times 32 minus 32 fifths minus 16 thirds plus 48 8. Now, just check my math here. We're going to figure out what this is. Minus 32 divided by 5 minus 16 divided by 3 plus 48 times pi, and I get 113.935. Just as a check, this is the exact answer. Not simplified, but it's exact. Now let's see if I type that in correctly. So math 9 from 0, enter to, oh, keep doing that, to 2, and it's 25 minus parenthesis x squared plus 1 close parenthesis, that squared dx, and I forgot to put the pi, so times pi 113.935. Got the same answer, so that looks good. Now let's go back and do the shell method, or the ring method. So now I'm going to do a slice horizontal, which means its thickness will be dy, and that slice will come down and hit down here. So it'll come out and go around. Hopefully this is looking like a piece of pipe to you a little bit, as opposed to the washer that was here. Okay, so a piece of pipe. To do that one, it's the 2 pi r, and the radius for that is the same as the radius was for the inside. It's y plus 1 more. Now, if you mark these x and y's, it's easier to see. Y plus 1 more from the center. We got 1 there plus the y, so it's 2 pi r times the height, which is x, but the slice is dy. So I've got to solve for x, so that's going to be the square root of y. And there's the integral set up, and that's y is going to go from 0 to 4, no, yeah, from 0 to 4, because that's the x-axis, 0 to 4. We're going to do these slices all the way up to 4. Okay, now let's just check and make sure we get the same answer here before I go through all the work. And so math 9, 0, 4. So this is going to be just for the, well, I can do, well, I'll just go x. Oh, I need an extra parenthesis. Parenthesis x plus 1, close parenthesis, square root x dx. Oh, and I got to take this times 2 pi. Notice I get the same answer. A little bit of a rounding issue with the calculator, but other than that, same answer. So this should be correct. Now, if you chose to integrate this one, it would be 2 pi integral from 0 to 4. So this is y to the 1 and y to the 1/2. So it'd be y to the 3/2 plus y to the 1/2 dy, and that's a pretty easy integral to do. So it's going to be 2 pi y to 5 halves divided by 5 halves plus y to the 3 halves divided by 3 halves, evaluated from 0 to 4. And again, 0 is not going to give us anything, so all we have to do is worry about putting the 4 in. 2 pi 4, square root of 4 is 2, to the 5th is 32 divided by 5 halves, or 2.5, plus square root of 4 is 2, cubed is 8, divided by 3 halves. And again, that should work out to be that. So that's that problem. Number 4, determine the work done pumping water out of a full inverted cone. So this is a circle, okay, full inverted cone. We're pumping the water out of it into a truck that is 1 meter higher. The diameter of the tank is 4 meters up here, so that means this is 2 meter radius. And the height of the tank is 3 meters. So I could put the axis any place. To make the equation of the line easy, I'm going to use it here. Just my preference, and so the y-intercept is 0. And so this line is y equals, it rises 3 as it runs 2, so it's 3 halves x plus 0. Now if you put it up here, it's y, and with the positive y down, it's negative 3 halves x plus 3. Okay, but anyway, I'm going to do it that way, this way. So I'm going to have to lift a slice of water up to the top and then up to the truck. So I got to find the weight of this slice, which is going to be mass density times the volume of that disk, which is going to be pi r. So if I'm going coordinate system here, the point on the graph is over x, and this is y. So it's pi x squared dy. That's the volume, pi r squared h. And I'm lifting it this distance, which is just going to be y. And I'm going to integrate it from y going, I'm lifting it y plus 1 more, y plus 1. And I'm going to, the water's between 0 and 3. So it's a dy, so I need to replace x squared. So x is equal to 2/3 y. So I'm going to have 62.4 pi integral from 0 to 3 of 2/3 y squared. That's 4/9 y squared times y plus 1 dy. I could multiply the y squared, take the 4/9 out, multiply the y squared times both of those, and integrate it. It's a fairly simple integral to do, but you don't have to. And we'll go 62.4 pi math 9, 0, 3, 4 divided by 9, x squared, parenthesis, x plus 1, dx. All my y's are x's. And get that it's going to take 2,548 rounded. This is in, wait a minute. These are meters, this is pounds. I need to use not the 62.4, but the 9,800 because this is in meters. And use the metric weight density of water. So go back and change the 62.4 to 9800. And then my answer will be in newtons. So it's 400,238. 400,238 Newton meters or joules. Same unit. Okay. All right. Determine the pressure at the bottom. The pressure depends only on the depth. So this rectangular tank has this tank has a height of 25 feet. Its top dimensions is 18 by 6. This looks like the small one and the long one to me. So I'm going to call it 18 this way and 6 this way. You could have done it the other way, that doesn't matter. To find the pressure on the bottom, well, the pressure at the bottom of the tank depends only on the depth. And since this is in feet, we're going to use 62.4 pounds per foot cubed. And if we multiply by the depth, and see this is not completely full of water, it's only filled up to 23 feet, 2 feet from the top. So we're going to take it times 23 feet, and that'll cancel one of them and leave pounds per square foot. Pressure is either pounds per square inch or pounds per square foot, and so we'd have the right units. So all we have to do to get the first answer here is 62.4 times 23. Pressure at the bottom is 1997 pounds per foot squared. Now, you could have said, let's figure out the total weight of the water, and done 62.4 times, see, that's a volume, so I have to take it times the volume, so I take it times 6 times 18 times 23, and that had been the weight. Now the weight would be pushing on the bottom, so we'd have to divide by the area of the bottom that it's pushing on, which should be 6 times 18, and this would give us the same answer because these cancel out and we get that. So you could have thought of it that way. Figure out the weight, and then the force due to the weight divided by the area it's landing, pushing on, and that'll give you the pressure on each square foot. Okay, now we're supposed to figure out the pressure on the larger side. So that'd be the 18. So we're going to use the pressure at that depth. So I'll just put my coordinate system here, x and y. And so this will be the rectangle will have a dy height and the length is 18. And the pressure at that depth is, this is y. So this would be 23 minus y. So that's the depth. So it would be 23 minus y, the depth, which gives you the pressure, when you take it times the density, 62.4, times the depth gives me the pressure at that depth. And that pressure is pushing on how much area, because this is per cubic foot. This cancels one of the feet, so now we've got square foot. And this area will be square feet, so we're going to take it times 18 dy. That's 18 long dy height, so that's the area, and this is the depth. So this is a volume that cancels the volume on that. And we need to add the pressure that's here, which is going to be more than the pressure down here, which is going to be, going to be less than the pressure down here, which is going to be less than the pressure here. And the least pressure is going to be at the top. So we want to add up all the pressures when y goes from 0 to 23. And so this is going to be a force, so we're going to figure out how much push on there is on each of these pieces, and we're going to go 62.4 math 9 0 23, and we got 23 minus x times 18 dx. All my y's are x's. Press enter, and I get the amount of force on the side in pounds is 297,086 pounds of force trying to push that side out. It's a lot of push. 2,000 pounds is a ton. 30,000 pounds is a lot of push. Okay, got one more to do. A couple problems on less in this 2 parts on this. So 4 isn't the problem, but infinity would be. So we're going to go the limit as b goes to infinity of 5 of the integral 4 to b of 5x to the negative 7 fifths dx. Now I wrote it this way, hopefully, so that it would be easy for you to integrate. Now we got to keep the limit because we're not doing the limit yet. We're not considering what happens to this when it goes to infinity. We're going to figure out what this is. The 5 stays. The integral of x to the minus 7 fifths, we have to add 1, which would change it to x to the minus 2 fifths divided by negative 2 fifths. Evaluated from 4 to b. And so now we're going to do that. We're not taking the limit yet. We're just evaluating this by putting in the limits. So we're going to have the limit as b goes to infinity. Put b in here, and we've got 5. Now the negative power says this should be in the denominator. X to the 2 fifths times a negative 2 fifths. Oh, and x is b, so b, should have said b to the 2 fifths down here, minus, I'm going to put 4 in there, so I got 5 over 4 to the 2 fifths times negative 2/5, which is going to be, now as b goes to infinity, since this is a positive power, this is in the denominator, even though it's a root, the fifth root squared, a root is still going to go this is going to go to infinity, and since we're dividing by it, this whole fraction is going to get smaller and smaller and smaller. Now, if you need to see it, you can type this into your calculator and look at the graph as you go further and further to the right, and you'll see it gets closer and closer to 0. And so this will be our answer. So now we are taking the limit, so I don't need to write this anymore. And the negative cancel, so I get 5 over 4 squared is 16, fifth root of 16, and the 2/5 turns into 5 halves when we invert multiply. So we get 25 over 2 fifth root of 16. Now, if you didn't take it that far, that's fine. Or if you took it to a decimal, that's fine. Let's see, that would be 25 divided by 2. Oopsie, I better put parentheses here. Parenthesis 2 times 16 to the 1/5, or 0.2. That's 1/5 power. Oop. So this works out to be 7.18 approximately. So it converges. Now let's take a look at this one. Now 0 doesn't cause any problem, but 5 in here makes the denominator 0. So we're going to do the limit as b approaches 5 of the integral 0 to b of 3 over 5 minus x dx. We're just going to integrate this, so we're not doing the limit yet. We're not thinking about what happens when b goes to 5. So we've got to leave that questions on here. B goes to 5. I can do u sub, and du would equal negative dx, and so this just becomes 3 over u, which integrates to 3 ln of that. Evaluated from 0 to b, since I went back to x, so I don't have to change my limits. If I didn't go back to x, I left a u, I'd have to change these with this formula. So now I can put in the b, so I haven't taken the limit yet. So I got 3 ln 5 minus b, an absolute value, minus 3 ln of, put in 0, of 5. An absolute value, but 5 is positive, so I don't have to worry about that. And now I can think, what goes on as b goes to 5? Well, 5 minus 5 is 0. What is ln of 0? So let's take a look at, well, we can first of all say, what is ln of 0? And it says problem. How big of a problem? Let's take a look at the graph. So we go to ln x And zoom forward as we get uh, as the denominator gets closer and closer to 0, this goes off towards negative infinity. So this part explodes. Very, very big number, but negative. And so this one diverges.